So in today's video, we're going to just go ahead and delve into integrating absolute value functions. And so as a little bit of a reminder from the previous video, whenever we're taking the integral, the definite integral of a function from a to b of f of x dx, then we can just write that as the integral from a to c of f of x plus the integral from c to b of f of x, where c is contained within the closed interval from a to b. And essentially, this is going to really help us when we're integrating absolute value functions, just like it helped us when integrating piecewise functions, because the absolute value function is in fact a piecewise function. It can be defined in terms of two intervals, the interval over which kind of the, I guess you could call this the argument, the input is negative, and then we have to, when we input that into the absolute value, it becomes positive, or over the interval where it's positive, and then when we input it into the absolute value function, it just remains positive. And so with that in mind, let's go ahead and do a couple of examples. And so here we're taking the integral from 0 to 4 of the absolute value of 6 minus 3x dx, right? This very simple linear function. And essentially, when we want to determine what our c value should be, we just have to think of when this piecewise function, when this absolute value function changes its definitions. For what value do we shift from one piece to another piece? And so let's go ahead and see. This is going to occur whenever kind of our input, which we can refer to as our argument, whenever our input changes signs. So 6 minus 3x, so when is this going to be less than 0? Well, this is going to be less than 0 whenever 6 is less than 3x, or whenever x is greater than 6 over 3, which is just 2. So essentially, for every value of x that's greater than 2, our input is going to be, or when we put the absolute value into our function, we're going to get the negative of our input, right? And so that essentially tells us that for this interval, 6 minus 3x, or the absolute value of that, is just going to be negative 6 minus 3x, right? Because whenever we apply the absolute value, we're taking the negative of a negative quantity, so we end up with a positive quantity. And we know that whenever x is greater than 2, our argument is going to be negative, and hence, when we take the absolute value, we have to take the negative of that to become positive. And then with that in mind, we know that 6 minus 3x is going to be greater than or equal to 0 whenever x is going to be less than or equal to 2, right? And that just comes from the fact that we're kind of just taking the negation of x is greater than 2. And so with that in mind, we can separate out this integral into two different parts. So first of all, we can take the integral from 0 to 2 of the positive version of our input, so 6 minus 3x dx, and then plus the integral from 2 to 4, this is when our input, whenever x is greater than 2, when our input becomes negative, we're going to take the integral from 2 to 4 of the negative version of our input, so negative 6 minus 3x dx, right? And then this just becomes some very simple integration over here. So the first portion will become 6x minus 3 over 2x squared, right? And we're evaluating that from 0 to 2. When we evaluate this thing at 2, we will get, 12 minus 3 over 2 times 4, which is just going to be 12 minus 6, which is just 6. And then when we evaluate this at 0, it becomes 0, so that just disappears. We get 6 minus 0. And then over here, we can kind of remove this negative sign, and it'll become the integral of 6x minus 3x squared over 2 from 2 to 4. And then right over here, we're subtracting. When we evaluate this thing at 4, we'll get 24 minus 16 over 2 times 3, so 24 minus 24, which is 0. And then when we evaluate this thing at 2, we should just end up with 12, right? Or not 12, sorry, 6. So this becomes a negative 12 because we're subtracting them. And then ultimately we get 6 plus 6, which is equal, or not 12, 6 plus 6, which is equal to 6. Sorry, my mind is just going ahead of myself. This ultimately becomes 12, and that's the answer for our integral. And then next up, we're taking a slightly more advanced example over here, the definite integral from negative natural log of 2 to ln of 3 of the absolute value of e to the x minus 1 dx. And so again, we can just look at whenever e to the x minus 1 is going to be less than 0, that's only going to occur when e to the x is less than 1, or whenever, if we take the natural log of both sides, whenever x is less than 0. And then with that in mind, we can say that e to the x minus 1 is greater than or equal to 0 whenever x is greater than or equal to 0. And so then we can just go ahead and separate out this integral. This becomes the integral from the negative natural log of 2 to 0 over this interval. E to the x minus 1 is negative, and hence we have to take the negative of it when we apply the absolute value. So negative e to the x minus 1 dx, I can just write that as 1 minus e to the x, 1 minus e to the x, plus the integral from 0 to the natural log of 3 of the positive version, which is just e to the x minus 1 dx, and then we can just go ahead and integrate. So this will become x minus e to the x. We're evaluating that from the negative natural log of 2 to 0. When we evaluate it at 0, we get 0 minus e to the 0, which is just negative 1. When we evaluate this at negative natural log of 2, we get, that's going to be what, positive natural log of 2, and then minus e to the x, or minus e to the negative natural log of 2 is just going to be plus 1/2, and so negative 1 plus 1/2 is going to be just negative 1/2, right? And then this portion over here, we have plus the integral from 0 to the natural log of 3 of e to the x minus 1. That's just going to be e to the x minus x, evaluated at natural log of 3 and 0. And so we get plus e to the natural log of 3 is just going to be 3. And then minus the natural log of 3. When we evaluate this at 0, we just end up with 1. 3 minus 1 is 2. And so that just becomes 2. And then ultimately 2 minus 1/2 is just going to be 3/2. Natural log of 2 minus natural log of 3, we can just write that as plus ln of 2 over 3. And that right over there would be our final answer. So I hope this isn't too confusing. It really just comes down to being familiar with integrating piecewise functions and knowing how to kind of break the integral up into the two individual pieces and what c value to pick.